We are now ready to talk about rotations, projections, and more tangible movements that we can do with matrices. So for now, we're still on computation so that we can better understand how things work. We are going to find the standard matrix for counterclockwise rotation about the origin by an angle of 120 degrees in R2. We have standard matrix. So in your textbook, I believe in section 6.1, you can find a standard matrix for in one of the exercises for counterclockwise rotation by an angle of theta. So we can reconstruct this from scratch, or we can trust it and just verify it, make sure it works. So we have counterclockwise rotation by a general angle of theta. We want counterclockwise rotation by 120 degrees. If in your homework you might have to find clockwise rotation, then of course your theta, the angle that you put into these trig functions, is going to have to be negative. So you're going to plug in negative 120 degrees for opposite direction for clockwise. So in math, we know everything positive is counterclockwise. Excellent. So now what I'm going to do is I'm going to use a theta of 120 degrees, and I like radians better, so you can quickly make a change, multiply by pi over 180 degrees, maybe you remember that, and if you simplify this, you get 2 pi over 3. So I'm going to use a theta of 2 pi over 3 for this. Now, I feel like this is a good time to do a quick review of trig, because we haven't really used trig so much this semester. So to figure out sine and cosine of 2 pi over 3, maybe you remember this table, pi over 4, pi over 3. These are the first quadrant angles. And there is a way to remember so you can put a staple, so to speak, of square root of blank over 2 everywhere. And so this is a quick way to remember what this equals, what the angles equal, and then you can fill in with 0, 1, 2, 3, 4 in here. Of course, if you simplify this, you get the actual values of the first quadrant angles. So for cosine, you would copy them backwards. So that's 1. This is square root of 3 over 2, square root of 2 over 2. Another one that we are interested in here is 1 over 2, right? That's the same as this. And square root of 0 over 2 is, of course, 0. So now I am going to use the standard matrix here for the transformation t as cosine of 2 pi over 3, negative sine of 2 pi over 3, sine of 2 pi over 3, and cosine of 2 pi over 3. Now, you can use the acronym all students take calculus to realize that 2 pi over 3, as it lands in the second quadrant, at 2 pi over 3, sine is positive and cosine is negative. So then we can come up with the matrix, the transformation matrix, the standard matrix. Cosine of 2 pi over 3 is going to be, let's see, cosine of pi over 3 is 1/2. And because we're in the second quadrant, it's going to be negative 1/2. Of course, this is the same entry, so I'm going to put a negative 1/2 diagonally down. I'm going to use the sine of 2 pi over 3 first. Sine in the second quadrant is positive, so it'll be the same value as sine of pi over 3, which is square root of 3 over 2. So this is square root of 3 over 2. And since the counterclockwise rotation formula has a negative in this entry, we're going to have this be negative square root of 3 over 2. Now, using this matrix, we can find the image of V under this transformation. So for part B, I'm going to rotate 2, 2, this vector 2, 2, by an angle of 2 pi over 3 using matrix multiplication. Now, because I have so many fractions here, I can see that everything is divided by 2. So I can simplify my standard matrix just so that I'll have an easier time with the computation and take out the 1/2 from each entry. It's thundering outside. During the last chapter, we had hail. Now there's just a very big thunderstorm. So let's see, -1, negative square root of 3, square root of 3, -1, right? So effectively what I did, just because I'm about to multiply by this matrix, I don't want to have to deal with all these fractions, I factored out the 1/2, and we know from properties of matrices that that is allowed. So now I'm about to look for the image of the vector 2, 2 under this transformation, counterclockwise rotation by 120 degrees or 2 pi over 3. So to do that, we're going to do left multiplication by this matrix. So we're going to multiply on the left the vector that we're starting with, 2, 2. I am going to keep the 1/2, and then the first entry in my image matrix is going to be -2 minus 2 square root of 3. And the second one is going to be 2 square root of 3 minus 2. We can, of course, now bring the 1/2 in. So if we divide everything by 1/2, our new vector is going to be, let's see, -1 minus square root of 3. And down here, we have square root of 3 minus 1. So effectively, what we did is we figured out where I will land if I were to start with the vector 2, 2. This was my vector 2, 2. And rotate it by 2 pi over 3. So we're going to 2 pi over 3. B pi over 4. So it'll go down here. Let's see, the x would be negative, and this would be positive, so we're going to end up here somewhere. So this new vector is -1, minus square root of 3. That's the first entry. Let me do that again. So this will end up at -1 minus square root of 3, right? The x is negative, and the y value is going to be square root of 3 minus 1. That's barely positive. Square root of 3 minus 1. We just lost power, but my generator kicked in. Excellent.